All right, today we're adding and subtracting radicals. And if you remember from algebra, we need like terms to add or subtract. So if I gave you this problem right here, a lot of you would be very happy because you'd be back in Algebra 1. 3x's minus 5x. They are like terms. So we can add them together. 3x and minus 5x. We group together in our mind. And then we have this little plus 2y hanging out here on the side. And we get negative 2x plus 2y. There's no more that I can do with that. It just said combine like terms, and I did. So moving over here, there's absolutely no difference when we look at radicals. We need like radicals in order to add or subtract. So in our mind, we'll take 3 radical x and minus 5 radical x and group them together because they have the same radical, radical x. And then this poor 2 radical y has got nobody to combine with. 3 minus 5 is negative 2 radical x plus 2 radical y. Notice it's the same answer, just one is variables and one are radicals. All right, 8 radical 3 plus 9 radical 3. They're asking you obviously to add. Well, it's kind of easy, but you have the first question you should always ask yourself. And we have a friend here today to help us with that question. Ready? Jack looks at that and says, do I have like radicals? And then he answers, yes, I do. He has like radicals. Right here. This is a radical 3, and this is a radical 3. So all we have to do is count up how many radical 3's I have. I have 8 here and 9 here, so I have a total of 17 radical 3's. Hey, thanks, Jack. That was pretty easy. Uh-oh. Hey, Jack, can you help me again? All right. Do I have like radicals? No, I don't have like radicals. This is a radical 54. This is a radical 24. They are not like radicals. So we still have an unhappy Jack over here. But we have another friend who can help us. And this friend is MC Hammer.
Ring the bell, school's back in. Break it down.
Haha, nothing like bad 90s music to help us with math. All right, so we got to break this down. So we're going to take 54 and we're going to look for a big perfect square that goes into 54 because we have to break it down. So let's see. I could use 9 times 6. Yeah, that seems to work. 9 is a perfect square, and times 6, so that gets me 3 radical 6. And now, like MC says, I got to break down 24. So let me think of a perfect square that goes into 24. 4 times 6. All right, so that would be 3 comes along for the ride. 24 gets broken down into 4 times 6. I can take the square root of 4, it's 2. I can't take, and once again, do I have like radicals? Yes, I do. So now Jack is happy because we have like radicals. We have radical 6 and radical 6. So what are 3 radical 6's take away 6 radical 6's? -3 radical 6. Hey, thanks Jack and MC. All right. All the laws of math still apply here. So in other words, they are asking us to subtract these two numbers. Well, the first thing I'm going to do is I am going to distribute. I'm going to take this negative right here and distribute it. So I have 10 minus 8 radical 6 minus radical 216 minus 12 because I distribute. Now I'm going to rearrange and put my like terms together. So that means 10 and minus 12 are like terms. And, well, -8 radical 6, -216 radical. What did Jack ask? Do I have like radicals? No, I don't have like radicals. So if I don't have like radicals, I gotta
Ring the bell, school's back in. Break it down.
That's right, I'm sure you're all getting up and doing your hammer dance right now. So I gotta break down my radicals. Thanks, Jack. You can go back there now. All right, so there's no perfect square that goes into 6. It can't get broken down. But 216, is there a perfect square that goes into 216? Well, if you look on that square root list that I made you copy down yesterday's notes, you will realize that 36 times 6 gets me 216. So let me take some time and break it down. So that's 6 radical 6. I got the -8 radical 6. And, well, I can do 10 minus 12 and get -2. All right, so oh, don't need to have hammer time again. So I can add like radicals together. And in this case, I finally have like radicals right there. So -8 radical 6 take away 6 radical 6 gets me -14 radical 6's. And then the -2 comes along for the ride. And that is my final answer. Oh, look at all these radicals staring at us. Wow, we got a lot of work here to do. Let's take MC Hammer, put him over there. All right. Once again, Jack asks, do we have like radicals? No, we do not have like radicals. This is a radical 96, this is 24, this is 600. Oh, wow. All right. So you know what we have to do now? Everybody, sing it with me.
Ring the bell, school's back in. Break it down.
All right. Let's take this. The x is outside, and a perfect square that goes into 600 would be 100. And then 6. Wow, I got a lot of breaking down to do in this one. The 24 can be broken down into 4 and 6. And notice I always put the perfect square first. It makes it easier. And then this x squared. All right, and 96. Let's see. Well, I'm going to take a wild stab in the dark here, but if I've got a radical 6 here and a radical 6 there, I'm going to see if I can get a radical 6 there. So my first guess is 6. And let's see, does 6 go into 96? Yeah, it does. 16 times. All right, so there are all my like radicals. That was easy. Whoops, sorry. Sorry again. I'll get back to you. There we are. There's the right page. Delete that. Let's get rid of all these little circles now. Okay, so what have we got here? X. Can I take the square root of 100? Yep, it's 10. Can I take the square root of 6? Nope, it stays in a radical. Minus 2. The square root of 4 is 2. And I can't take the square root of 6. Can I take the square root of x squared? Yes, and I get x. So that x comes down. 4x. Can I take the square root of 16? Yep, you can get 4. Can I take the square root of radical 6? Nope. All right, so let's start combining things here. Let's clean this one up. When I clean that one up, I get 10x radical 6. Let's clean that one up. 2 times 2 is 4 and an x, so I get 4x radical 6. And clean this one up. I get plus 16x radical 6. Now I have like radicals. Everybody's a radical 6. Everybody has an x. So now I can just subtract. 10x radical 6 minus 4x radical 6 is 6x radical 6. Add on to that 16 x radical 6's, and I have a grand total of 22x radical 6. That's my final answer. Okay, just the last one. Help me out, Jack. Do I have like radicals? No, I do not. So since I don't have like radicals, one last time.
Ring the bell, school's back in. Break it down.
All right, so 200, 8 to the 7th, and then over here 50 and 8 to the 7th. So if I keep breaking it down, 200 can break down into 100 is my perfect square, and 2, and 8 to the 7th. What's a perfect square out of 8 to the 7th? 8 to the 6th. Remember, since it's a number 2, perfect squares under radicals, their powers have to be a multiple of 2. 50 is 25 and 2. And 8 to the 7th, I'll take out 8 to the 6th because that's even, and we know 2 can go into 6 3 times. And then there's a radical a. All right, back to the beginning. Square root of 100 is 10. I can't take the square root of 2, so that stays in the square root sign. The square root of a to the 6th is a cubed, so that goes out front. And I can't take the square root of a, so that goes onto the radical. Square root of 25 is 5. Square root of 2 I can't do, so it stays in a radical. And the square root of a to the 6th is a to the 3rd. And radical a stays under the radical. Okay, so are they like? Let's check it out. This is an a cubed radical 2a. This is an a cubed radical 2a. So if I do my math, 10 minus 5 is 5. a cubed radical 2a's. Yay! This lesson was fun.